Welcome once more, YouTubers. This is Uncle Pythagoras signing in. We are continuing with the preparation for examination, which is the practice for paper 1. Today we are going to look at the Western Cape Province, September 2024. It is all about the maximum and the minimum. And do not forget to like and subscribe to my YouTube channel. We are going to take everything that comes our way. If you drop your questions in the comment box. Thank you very much. Today we are going to look at this question. It reads as follows. The flower pot below is in the shape of a cone. R is the radius of the base and H is the perpendicular height of the cone. The slant height of the cone is 12 centimeter. This is what the cone looks like. We have the cone here, right here. This is our height from the center up until here. And then we have the radius R. Then the slanting of the height of this cone is 12 centimeters. It is given as 12 centimeters. Now we are required to calculate 9.1 to show that the volume of the water needed to fill the entire flower pot can be expressed as V is equals to 48 pi h minus 1/3 pi h cube for 3 marks. Now, before we can go any further, we were given the formula for volume, formulae for volume. It is as follows. We have, let me write this, that side, 12 centimeter, that side. We have V is equal to LBH. Another V is going to be pi R squared H. Another V is going to be 1/3 pi R squared H, and the last one is 4/3 of pi R cubed. So you will choose which volume you need to use. Remember, this is a cone. The first one, the first volume, if you can check, remember very well, it is a cube. The second one, it is a second. The third one, it is a cone. The last one is a sphere. So we are going to take this one because we are dealing with a cone. We are going to take this one. But you are given the formulas in the exam room. Don't panic about which one to use. Now, the solution. The solution, we are going to take that formula that says V is equals to 1/3 pi R squared H. They say that show that the volume of the water needed to fill the entire flower pot can be expressed as V equals to 48 pi h minus 1/3 pi h cube. If you can check here, we have something like this. We have something like this in that that drawing there. We have something like this. We have our 90 degrees here. We have our R here. We have our H here. We have our H here. Then we have a 12 centimeter here. We have 12 centimeters here. What do you see when you see a figure like this one? You remember Pythagoras theorem. Pythagoras theorem says R squared is equals to x squared plus y squared. So the radius here, our R here, it is going to be this one. It's 12 centimeter squared. Is equals to, here the x is R squared, and the y is h squared. Let's rearrange all this in terms of R. So we are going to say R squared is equals to, a 12 squared is the same as 144. Check with me. In the exam room, make sure that you don't cram these values. You must make sure that you use them correctly. Yes, 144. Then we take this h that side minus h squared. Now we have the value of R here as that. Then we come and say, but V is 1/3 pi R squared h. Now we must express R here as this value. We must put the value of R, this one, here as substitute it in the formula here. So V is 1/3 pi h. Then we put R. R is the same as 144 minus h squared. Then we multiply throughout here. Remember, the volume must come to this. The volume must come to 48 pi h minus 1/3 pi h squared. So we multiply throughout here. 144 divided by 3 is equals to 48 pi h minus pi, it's 1/3 pi h times h squared is h cubed. We have proven that it can be expressed in terms of V. Now we come to 9.2. 9.2 says that the gardener wants to maximize the volume of water in the flower pot. Determine the value of H for which the volume is a maximum. Determine the value of H for which the volume is a maximum for 3 points. We are going to take it from here. Now, if you talk about minimum and maximum, you know that somehow you have to do what? To form the derivative. This is the dV in terms of dH. We are deriving the volume in terms of H is equals to, here it is going to be 48 pi minus 1/3 multiplied by 3 pi H squared. A 3 cancels, a 3. We have A. We know that somehow the derivative is going to be A, 0 at some point. 48 pi minus pi H squared. Now we take H that side because they want us to determine H for which the volume is a maximum. We determine H for which the volume is maximum. We take this pi minus pi H squared on the left hand side. You have a pi H squared is equals to 48 pi. Now you divide throughout by pi. You divide by pi. Pi falls apart. You are left with H squared is equals to 48. Then H is equals to the square root of 48. The square root of 48 is equals to 4 square root of 3, which is the same as 6.9. 6.93. Did they tell us the decimal place? No, we can leave it at 2 decimal places. As for the first one said, we must leave 2, the 3 decimal places. H is going to be 6.93 centimeters or 4 square root of 3 centimeters. Now this is the simplest part of the minimum and the maximum, the application of calculus. If you have any problem, just drop it in my comment box. We will deal with it before we can go and write paper 1. Thank you very much for those who have subscribed. Please do not forget to share it to others so that they can get their understanding before they can go and sit for their final examination. A very good luck from me. You guys are very brilliant. I trust you. I believe in you. You are our future leaders. Take care of yourself. Until we meet again next time, because we are going to load some more of the videos to prepare us for the final examination for paper 1. Thank you very much. We'll do the same for paper 2 next week. Thank you very much. Have a great one. Do not forget to like and subscribe. Uncle Pythagoras signing out. Thank you.